Hi, so today we're going to be going over a machine for Mr. Mayor. So this was sent in with the no backlight issue. And we have some funky shit going on here. There's a keyboard cable that's like going above the board, below the battery, and all wrapped up. Let's figure out what's wrong with the backlight issue first, and maybe I'll fuck with that keyboard mess a little later. So let's turn it on and just confirm what's going on with it before we do anything. So we turn it on. It chimes, yay. Let's see if I have a picture on the screen. So one of the easiest ways to do that with a Retina is with an LED ring light from an old Microscope. So you just take that ring light and you put it by the Apple. See, this is one of those things now, because you got to be careful when you're doing this. You got to be careful, because this ain't no backlight. This is no image. There ain't shit on the screen. See? So a lot of people will think, oh, the problem is that I don't have a light on the screen. When the actual problem is that this screen has no picture or that the screen is not recognized. These are different problems. And then you get even further down the rabbit hole where people are calling it, nothing on the screen or no backlight when there's no V-core and there's no actual power going to the CPU. This chimes. So since it chimes, it tells me that at the very least the CPU is working. But at the moment, there's nothing on the screen. So the first thing here to be careful of is you don't want to chase a no backlight rabbit hole on a board that has no image on the screen. So the first thing we want to do is we want to see if power is actually getting to the LCD. So let's just switch over here to the schematic and we can start talking about what's going on with the screen. So this is an 820-3787 board. So we're going to go over to the LCD connector here and we're going to see where power goes. So it's J8300, right? So let's look on the schematic here for J8300. Fuck you, Adobe. Thanks for nothing. Mother. Okay, take two. No, I don't want any foreign fonts. Display my schematic. I hate being sick. Okay. So PP5 VSO LCD, 5-volt rail to power the LCD. That is supposed to be coming in on pins 28, 29, and 30. Ignore pins 33 through 41, and they don't exist. They're just here to fuck with you because Apple likes making life miserable. I think they finally started to figure out that we have access to these schematics, and I think one of the things they did as a way to screw with us is they've just made some of the information there a little bit incorrect just to make life miserable. So let's get an idea what's going on with that. So let's plug this thing back in over here, and we're going to measure. Might as well make it so that you can see what I measure. Come here, little oscilloscope. All right. Move. Okay, we plug it in. I'm going to take my oscilloscope probe over here. Okay. I can't really do here. There we go. Mounted on my S5 phone screen, because there's no way that anything's breaking in S5, as I like to say. So we're going to take one probe here, put it on ground, the other probe, and put it over here. So we have 5 volts going to the LCD. And let's check on the pins themselves just to make sure that I'm not losing it. So we have 5 volts going to the actual screen. Let's see where backlight is supposed to be on here, shall we? Because that may give us a little bit of a hint as to what's going on. So let's check. Oh, backlight is on pin 1. It's called PPV out _SO _LCD backlight. Right? Okay, so let's see where that shows up on this board. So we should be able to see that on a bunch of these capacitors over here. So let's measure it. And again, I'm not expecting to see anything. I'm just curious because different levels of voltage can say different things are wrong. If you get 0 volts, maybe a blown fuse. You get 12 volts, okay, it's at least power is going through, but it's not boosting. You get 60 or 50 volts. The problem there is that it's not. Problem if you get 50 or 60 is that it may not see the screen is actually connected. So the problem there would be the line from backlight output, backlight boost to the LCD connector. So here we have 0 volts on backlight, which speaks to maybe an issue with fuse. Another thing to think about with the retinas, and again, this is something that you should know because it's a common mistake and common problem. So I said a lot of people think that there's no backlight when there's no video. Another problem with the retina is people do the opposite because they think there's no image when there's no backlight present because it is so hard to see the screen on a retina without a light. I don't know what they did or what type of different screen materials get used on these newer model screens, but without the light there, you damn near can't see anything. So since it is sending 5 volts, and again, I want to show you a little bit of how this works just so you have an idea. The way this works, see this PP5 ESO LCD? This is not going to come in without LCD power enable being there. LCD power enable comes from, let's just show you here. This comes from let's see, you have U9600 is one of the places that you'll find it. Okay, so U9600 is a MUX. So you have integrated video over here with the Iris graphics, but then you also have the graphics chip, the NVIDIA graphics chip. And then also you have DisplayPort here, and then you have eDisplayPort, and you have HDMI. This is all a lot of stuff to manage, and Apple has a chip that manages it. Now, this sees the graphics, this sees that there's a screen there. This is obviously sees that there's a screen there. If it didn't see that there was a screen there, it would not be showing 5 volts there. It would not be sending out that signal to allow 5 volts to go through. And we use something called there's a DDC circuit that detects that there's actually that there's a screen there. That's responsible for detecting it. So you know when you plug in a VGA monitor or a DVI monitor, the computer then magically knows, oh, hey, there's a monitor there. Oh, hey, that's a 1600 by 900 or a 1600 by 1200 screen. That's part of something called a DDC MUX circuit. So that's what you're looking at over here. Anyway, long story short, if we see 5 volts at the LCD being detected is not the problem. Most likely it is a backlight problem, and the only issue here is that I thought I didn't see a picture because I'm sick and going blind. So let's go back. Oh, you couldn't see me. Oh, well. No big loss. I'm sick anyway, and I'm not that handsome. So we're good. Let's check the rest of the backlight circuit. So PPV out, LCD backlight. Where are we? Okay, so first, it starts, this is a standard DC to DC boost circuit. The way this works is you're going to have, let's make sure that you see what I see, all right? You have a certain low DC voltage going through here, right? Now, this is going to open based on other signals, and I'm not going to get into that right now. But this is a transistor that's simply going to let power through to the backlight circuit. Now, the way this is going to work, I've already explained this in the DC to DC boost circuit video, is you can only get power to move through an inductor so fast. So what's going to happen here when you short it to ground is that the power can't move through it as fast as it wants, and it's going to build up in certain areas. And you're going to have this like stopping short effect where at one certain point in the inductor, you're going, instead of having 12 volts, you're going to have 15. Because you have this coil, right? This coil that can store power. And if you try to shove all that power through it as fast as you can, it's not going to be 12. It's going to be 12. Then when it stops short, 12, 15, 18, 21, it's like stopping short in a car. Like you're driving in your car at 50 miles an hour, right? But you yourself, you feel stationary. When that car stops short, for 1 second, you're probably moving at 50 miles an hour. And it's kind of like the same thing going over here. So this thing is constantly switching, constantly stopping short. And then after this diode and in these capacitors over here, you're storing the backlight energy. So let's check along every part of the backlight rail and get an idea what's going on. So I'm going to turn the machine on again, and we will start with F7700. If we go to the board view over here, we will see where F7700 is. Okay, F7700 is over there. So let's see what we have on each side of the fuse. So we're going to measure over here, and we have on one side of this fuse, we have 13.3 volts. On the other side of this fuse, we have 13.3 volts, which means that power is getting through to the backlight circuit. Now we're going to check over here at Q7706. I want to see if power is getting through to the rest of this thing. So Q7706, let's see where that is. And I'm going to skip over the current sensing resistor. I've gone over what current sensing resistors are thousands of times. That's over here. That is just never the problem. And watch it be the problem here because I said it's never the problem. But 99% of the time, it's just not the problem. So CQ7706. By the way, I don't remember the last time I've actually had a backlight issue on a Retina that was a fuse. It's almost never the fuse. The fuse doesn't blow. The LCD connector blows. The LCD cable blows. Large traces in the motherboard will blow. But the fuse, oh, hell no. That thing never, ever the backlight fuse. Oh, no. Now, dare Apple design a machine where the shit actually works the way it's supposed to. The hardware works the way it's supposed to for longevity reasons. Oh, fuck no. We can't have that. Okay, so now we have voltage at the fuse, right? But we don't have voltage at the after it, at the end. So let's start going through each individual component in the line. So you have Q7706 over here, right? So Q7706 is this thing. So pin 6, that is going to be where we see the power on the output. So let's see if that is actually opening. And that's not opening. But it does have power on input. Now let's try to learn a little bit of how a basic transistor works. Now, as I've said, there are different types of transistors. There are transistors where the transistor itself will open and send power through when you have voltage on the transistor's gate, and there are transistors that will not open when you have voltage on the transistor's gate. So what I can do over here is we can Google the model number of that transistor and see what type of transistor this one is. So FDC 638APZ. Okay, so we search for the transistor and we get a data sheet. There's going to be a bunch of information here that I don't know anything about. Okay, so this is one of them transistors where if you have less voltage on the gate than you do on your source, hypothetically speaking, it should open. So on pin 4 and pin 3, those are going to be the pins that are of interest to me. So pins 4 and 3. So we're going to try to measure pin 4 up here. So pin 4 of this transistor has 13 volts, and pin 3 of this transistor has 12.4. So there's a good reason that this is not opening. So this is not opening because it is saturated. So over here, this is saturated. So now there are a couple of things that I'm going to think are to blame. Now, the way this works, again, so this over here, this takes 12.6 volts and sends it right over here to the transistor's gate. However, in order to get that voltage to drop, you have R7702 here, which is going to backlight SD. Now, this over here should short to ground to allow this voltage divider to work, to take voltage off of the gate so that this P-channel MOSFET over here can let the power through to the rest of the machine. However, it's not happening. Why is that not happening? I'm not sure yet. Maybe this chip is bad internally, or maybe it's simply not being sent the signal to it. Now let's see a little bit more about how this chip works. So you have this thing over here called EN. Well, I wonder what EN means. Maybe that means enable. Maybe that's why it's not enabled. Is there voltage on the enable pin? Is this actually going to ground the way it's supposed to? Is R7742 good? These are all great questions, and they're all things I'd love to start figuring out. So let's see where U7701 is on the board, and let's see where R7742 is on the board. With any other old board, these are things I have memorized, but since this is a newer Apple board, I have to actually look it up and pretend that I'm doing it for the first time. So we have R7742 and U7701. R7742, U7701. And if these are on the bottom of the board, I will scream because I don't want to take this mess apart. Okay, let's see. So we go over here, we make it full screen. And that 0 ohm resistor is in the middle. Oh, of course, you're really tiny. Go figure. Okay. Let's see what that looks like under the microscope. So we're going to go over here and get that under the microscope and get a little look at what that looks like. See you later. YouTube says good night to you. It's a little piece of shit in the middle. All right, let's see how many ohms that is. It's 0 ohms, like it's supposed to be. Now let's see if we actually have power present at the backlight enable tab. Oh, measuring that is going to be a bitch and a half. .2 volts. 3.2 volts. So we're going to do something bad right about now, so we can try to figure out what's going on. So what I'm thinking right now, I got a couple of things going on in my head. The first is that this chip is bad, and even though it's getting the enable signal, it is not allowing this voltage divider to come through. It is not allowing the SD pin over here to switch to ground to allow this to allow power through to the machine. The second is that this transistor is somehow internally damaged, and as a result of that, it's sending the 12 volts from the input to the gate and then not allowing it to go through on the source. It's not allowing this to go to there, because somehow this is getting sent to the gate, and because that's fucked up in some way, it's not working. I also forgot to check R7702, which is pretty stupid. I think I typed that in here. R7702. Did I put that in here? Because that's a really important one over here. If that doesn't work, then none of this is going to work. But let's just check that and that theory. But anyway, the bad thing I'm going to do, if you've watched this channel long enough, you know exactly what it is. I'm just going to check for a short after this. And if there is no short after this, I'm just going to solder blob forward to 1256 and see if anything blows up, and then go from there. And that's actually a good thing to do now. So I'm going to check both of those things now. So the first thing I'm going to do is I'm going to check resistance of R7702. After I check the resistance of R7702, I'm going to check for a short to ground on backlight rail. If I have no short to ground on backlight rail, then I will do something really, really bad. R7702 is 63.3 kilo ohms. The schematic says it's supposed to be 63.4 kilo ohms. Okay, fast forward ahead to the fun part. Let's see if there is a short to ground on the backlight rail. Let's see if is there a short to ground on the backlight rail. Is there a short to ground on the backlight rail? So that is diode. So we're going to measure right over here. So, oh yes, there is 0.002 voltage drop to ground. You know what? You know what, Apple? This is pretty fucking cool. You know what? I don't give you credit where credit is due, and I think I may have even started off this video by complaining about the design of the new board, but this is cool. This really is pretty cool. So check this out. To prevent the fuse from blowing, and I may be nuts here for being wrong because I'm not even done. So check this out. So this is a short to ground over here, right? Now, on any older board, you know exactly what would happen. The power would go through here. There'd be a short to grounds over here, which would mean that it would shove all of this 12 volts through this circuit, or whatever 50 volts is coming out of here through this boost circuit out to the short to ground, and this fuse over here would get completely fucking sodomized. Or if the short to ground was after here, if the short to ground was in the connector itself, then the connector would just get burnt and crisped to pieces. The fuse itself wouldn't even fucking blow, even though it had sent enough power through to blow everything to pieces. And you wouldn't get anything to work. What happens here is this shit actually senses that there's a short to ground and says, you know what? We're not going to blow the fuse. We're not going to let the fuse not blow and then destroy the connector. We're actually going to turn this transistor off. We're going to use this switch the way it should have been used 7 damn years ago when we put it on the unibody boards. But like, again, late beats never. You know what? You should have done it in 2008, 2015. It's about fucking time. So let's see what's causing that short. So I'm going to unplug the screen. And when I unplug the screen, I get no short at all. Okay, so what I'm going to do now is I'm going to take another Retina screen and plug that in. And if another Retina screen works, then I'm afraid you're just fucked because you're going to be paying a lot of money to fix that. So this is a Retina screen from back when we used to replace the entire assembly. When we replaced the entire assembly, if somebody wanted their old one back, we'd give it to them, but most people don't want this old stuff back, so we would keep it. And now we're refurbishing all of these and so I just took one to see if this one has a backlight. This went on for a second, but this one's actually too fucked to test if it has a backlight. So I'm going to get up again, and I'm going to get another one that looks a little less fucked up. Okay, got another one. I can't say this looks less fucked up. I'm just hoping that I picked a good one. I use the incredibly scientific method of and then stopping my hand at a random point to choose this screen versus another. Okay, we plug this in. Wait a second. This is not going to turn on the screen because I have the thing closed. Well, duh. Yeah. So the other one wasn't even fucked up. It was just that I had the computer closed. So as you can see, this actually has a perfectly fine backlight. There's nothing for me to fix here. You just have a messed up screen. Yeah. 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 If you need a new one of these, I don't know if you've seen what the prices are for them, but that is... And when you crack the screen, when you crack it, you need just a new LCD. When the light inside of this thing died and is shorting itself to ground, you're fucked. You need a new... You need this, and yeah, this is where you get a disheartening call from my salesman, because I used to deliver this type of bad news all the time, and it is luckily not my job anymore. I guess I'm delivering it kind of through YouTube. So this goes on the side. So that's all the troubleshooting done. Again, coolest thing to make note of on these new Retina boards, on the newest, on the 820-3787, I gotta say, I gotta give some props to Apple when props are due. I've been sitting here on this channel bitching for the past 3 years and how all their products are made like shit. Even the ones that are usable. I'm not going to say that they're bad for everybody. Apple products are very usable for a lot of people, and there's a lot of things with the software that make it easier to get things done. The hardware itself, you may like the way it looks, but the inside of the machine, I'm not talking about the processing power or the speed or any of that. I'm talking about just pure durability is usually shit. This computer, it senses, it tells that there is a short to ground. I detect the screen, I acknowledge the screen, but since there is a short to ground on the backlight rail, let's not send power through. Not let's blow a fuse that other people have to learn how to fix. Not let's send the power through the fuse and ignore the fact that the fuse exists, like in all the A1425s, all the early A1398s. They sodomize that LCD connector. They destroy it completely. None of that nonsense while letting the fuse sit perfectly fine. It actually detects that there's a short and says, you know what? Don't send power there. That's pretty damn cool. You know, I may not like Apple, but I'm fair. I'll give credit where credit is due. And this board is a step towards a more sustainable and a more durable design. And whoever at Apple who is responsible for putting this together, they deserve a raise. They deserve props. This is good.